Hi, and welcome to the second lecture in this unit about absolute location. Now, if you remember, when we were talking about the 5 themes of geography, we've only gone over one so far, location, and we've looked at the first half of that, relative location. So now, this is the second type of location that we talk about, absolute location. And if relative location defined where things were in terms of other things, absolute location tries to come up with an objective way of describing where things are without referring to any other thing on the Earth. And usually that's done using the latitude and longitude system. Now, latitude lines are these lines that go across, parallel, that is horizontally, and longitude lines are the ones that go up and down. So as you can see, when they meet, they form a grid. Now it's easy to get these mixed up with each other. What I usually do is I imagine that I'm climbing a ladder. And what am I touching? I am touching latitude, all these rungs that go back and forth. See, it's like a little ladder right there. So latitude's your ladder. Yay, that was easy. So first, lines of latitude. Once again, these are the lines that go left to right or side to side. The most famous of these, the one that you've heard about, is the equator, which goes right around the middle of the Earth, the place where the Earth is thickest. Kind of like a belt. It's generally pretty hot on the equator, except maybe right up here where there are really high mountains. In fact, it's so hot that when I was little, I was maybe 4 years old, I was on the equator over here in Indonesia, and it was so gross and so hot that I just kind of threw up all over everything because I was just a little stick kid and I was hot. But anyway, yeah, so that's the equator. It's hot there. All right, the equator, if we're measuring lines of latitude, the equator, we say has a latitude of 0 degrees. That's the way we pronounce that little thing the same way, the same way we talk about how hot it is, or when you're talking about degrees in geometry, if you've taken that class. So the equator, 0 degrees, but all the way up at the top of the world, you have the North Pole, which is designated 90 degrees north. Same thing at the bottom of the globe, you have the South Pole, 90 degrees south, and then all of the parallel lines up to those 2 points are something smaller. Like, for instance, this line is probably, let's call it 10 degrees north. This line right here, let's call it 45 degrees south. And you always have to write it out that way. If you just write, say, 10 degrees, we won't know which side of the equator you're on, and that's no good. All right, lines of longitude. If latitude goes east-west, longitude goes north-south, so up and down. The most famous of these lines is the prime meridian, and this passes through Greenwich, England, right there, just because of a little accident of history. That's where people were measuring it from, I believe. The Royal English Society of whatever, scientists, whoever came up with the system, wanted to make sure that it was centered right where they lived. So for that reason, we count from Greenwich. And the prime meridian is this line. And it too, like the equator, is at 0 degrees. It doesn't have a north or a south. Another very well-known line of longitude is the international date line. Unfortunately, on this map, we're basically, once again, looking at the prime meridian, but it is, luckily, exactly opposite the prime meridian, the international date line is. So it goes over the Pacific, over this area of the map right here, and it's where if you were flying in a plane to, I don't know, Japan or something, as soon as you passed over that line, if you were going from LA to Tokyo, you would suddenly jump forward in time by 24 hours, And if you were flying from the other direction, you would suddenly jump back 24 hours. But it doesn't really count as time travel because that's just an imaginary line that tells us where we make the arbitrary distinction between one day and the next day. The same thing that happens when you drive west past, I don't know, Nashville maybe, and you have to set your clock back an hour. But anyway, with these longitude lines, we count east or west from the prime meridian. So, for instance, the line very close right here, 10 degrees east. If we went the same, distance, either west or east from the prime meridian, we would be 10 degrees, either west or east. And you can go further to 60 degrees on either side. And when you get all the way around to the prime meridian, of course, you are at 180 degrees. You don't need to say east or west because it's either way. It's just 180 degrees at the prime meridian. So that is how the system works. Each of these combinations, you're at latitude first, comma, then your longitude number, and each of those will correspond to a single place on Earth. So, for instance, if you're looking at Columbia, South Carolina, we are at 34 degrees north, 81 degrees west. Anytime you say those coordinates, you can only be talking about Columbia, and anytime you say Columbia, South Carolina anyway, you can only be talking about those coordinates. So this is absolute location. Where Columbia is, how we describe it doesn't rely on any of these other little cities. It only matters where these imaginary lines are. All right, so I think you've got it. Those are the two ways of describing location. Good job.